Take one last look at this object model because there is something interesting to say about it. Look at the whole model from an abstract point of view. What do we have here? Well, we have a structure where some things contain data, blobs, and then there are other things called trees that contain blobs and other trees, so the entire structure is recursive. And the names of the blobs and trees, they are not in the objects themselves, instead they are stored in the containing tree. So you can have the same object, say the same blob or the same tree, pointed at by different trees with different names. Does this structure remind you of anything? Well, to me, it looks an awful lot like a file system. Just like in a file system, you have content, files or blobs, and nested containers, directories or trees in this case, and you can have links. The same file or directory can be reached from different places with different names. It's like links in Linux or shortcuts in Windows. In fact, you might argue that that's what Git is. It's a high-level file system built on top of your native file system. This shouldn't surprise us. After all, Git was written by Linus Torvalds, who wrote Linux. He is an operating system kind of person, so when he built a version control system, he built it like a file system. That's just the way he thinks. It's a version file system, of course, because it also has commits, which have versioning. And that's what we mean when we say that Git is a content tracker. So we have seen that Git is a persistent map at its core, and layered on top of that is a stupid content tracker that looks a lot like a version file system. In the next module, we will put this theory to work to understand the all-important next layer of the onion. You will see how easy Git branches are and how easy branch-related operations are once you know the basic model of Git. See you in the next module.